Welcome to section 9.5. We are going to be solving quadratic equations using the quadratic formula in this section, but before we get to that, I want to do a quick recap of what you've done up to this point with solving quadratic equations. Remember, a quadratic equation can be written in the form y equals ax squared plus bx plus c. Now, on all three of these we're going to solve, I've got y equal to 0, but they are still in this form, ax squared plus bx plus c. On the first one here, b is 0. That's why you don't have that linear term bx anywhere in there. But this one has the ax squared plus bx plus c. Same with this one over here. So that's why these are all quadratic equations, and you've learned how to solve those up to this point. So if you don't have that middle term, that bx term, that linear term, you can solve using square roots. You add the constant to the other side. In this case, you add 4 to the other side. And then you just take the square root of both sides to undo that square, remembering that the square root of a variable squared is the absolute value of that variable. And then you'd solve this equation to get your solutions, in this case, -2 or 2. And then I could write that in set notation to indicate that those are, in fact, the solutions. So that's the first one. The second one here, you could solve using factoring. So what does this factor into? Let's see. 2 and 1, and I need a positive x in the middle, so positive 2. Then I could use a zero product property and set each one of those factors equal to 0 and solve. And I get my solutions, x equals -2 or x equals 1. And again, I could write that in set notation. So the first one I did was solving using square roots. The second one is solving by factoring. And then the third one, another method that you just learned, is solving by completing the square. So to do that, I'm going to add 3 to both sides, because 3 does not complete the square. It does not make this left-hand side into a perfect square trinomial. The value that does make it into that perfect square trinomial is the value that completes the square. So I'm just going to put a little square here. And anything I add to one side of the equation, I must add to the other. So what value completes the square? Well, this guy right here has to be half of the middle term, the middle coefficient squared. Half of 4 squared, so 2 squared. That's the value that will turn this into that perfect square trinomial. Now, anytime you have a perfect square trinomial, we have the 2 different perfect square trinomial patterns that allow us to factor it. It will factor, since these are both plus signs, it will factor into x plus, here's my b value, so x plus 2 quantity squared equals 3 plus 2 squared. 3 plus 4 is 7. Then I can solve this using square roots. So square root both sides, remembering that the square root of a quantity squared is the absolute value of that quantity. 7 is not a perfect square, so I'll just leave it as a square root of 7. So my solutions I can get by saying x plus 2 must equal a positive root 7 or a negative root 7. X plus 2 equals positive root 7 or negative root 7. Subtract the 2 from both sides, and I get x equals -2 minus root 7. Subtract the 2 from both sides on this one, I get x equals -2 plus root 7, since that's a positive root 7. Put these in set notation, so -2 minus root 7 or -2 plus root 7 are the 2 solutions. So 3 different ways that you've learned so far to solve quadratic equations. Again, let me just type these out on here. This is solving using square roots. Solving using square roots. The one next to it here is solving using factoring. And this last one over here, this one is solving by completing the square. So 3 different methods. Today we're going to learn a 4th method, and ultimately there are 5 methods. We could also solve by graphing, and that one we didn't cover yet. Ultimately, you graph the parabola and look for the x-intercepts if it was set equal to 0 here. I don't know if we're going to have time to cover solving by graphing. We'll see what happens in the next week or 2. But you've learned 3 methods, and today here comes the 4th method, solving by using the quadratic formula. So we're solving quadratic equations using the quadratic formula. I can show you a proof of how to derive the quadratic formula, but you're not going to have to prove it. So maybe I shouldn't show it. Ultimately, the proof requires you to complete the square. If we were in class, I'd just have it on the board and I'd say, this is the proof of it. This is where it comes from. But maybe I can just find you a quick proof here and get you the link. So this is not the link to the proof on the bottom here, but let me get you a link real quick. All right, there you go. Two links. One is for the quadratic formula proof. So if you open up that one, it's going to bring you to this. And here is the proof of the quadratic formula. The first step, they just divide everything, both sides, by a. And then what you're going to do is move this constant to the other side in order to complete the square. So I know it looks kind of funky, but b divided by a is your middle term. So the value that completes the square is half of that squared. So what's half of b divided by a? Well, 1/2 times b over a, or b divided by 2a. And you take that number, or that quantity squared, that's the value that completes the square. Remember, you always complete the square so that you can factor. So using that perfect square trinomial pattern, we can factor that. And then on the other side, it's just a matter of simplifying. So what they're doing over here is just getting common denominators, and then ultimately, and after they get those common denominators, it combines into this. And then they're just taking the square root of both sides of these. And then they're skipping the step where they're showing the absolute value, but that's where that plus or minus comes in if you were to solve the equation with the absolute value in it. So I know this is kind of a mess, but again, I'm not going to have you prove this formula, but I want you to know where it comes from, because I'm just going to show you this mess here, and you're going to just look at this and go, well, where the heck did that come from? So that's where it comes from. Ultimately, the quadratic formula is just taking a quadratic equation using variables instead of numbers as your coefficients, and doing all the work to solve it by completing the square. And then that's the equation you get. So you no longer have to use completing the square to solve. You can just memorize this formula, plug in the coefficients, and get your answer. So it eliminates having to do the work. All right, so going back to this, there is actually a song to help you remember that, so I highly recommend you open up this link, you listen to this over and over again until it's ingrained in your brain. It's probably not going to sound very good if I just play it out here.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
And it starts getting more and more intense. I love that song. If we were in class, we'd be singing this together. Unfortunately, maybe from your point of view, fortunately, we're not in class, so we can't sing this together. But you can watch this video, and then just seriously sing that out loud, or at least sing it in your head, so you can memorize that equation. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That is the equation we're going to be using today, called the quadratic formula. All right, notice here it says a cannot equal 0 because we can't divide by 0, and if a was 0, this wouldn't be a quadratic equation. And b squared minus 4ac has to be greater than or equal to 0. Well, if this was less than 0, if this was a negative, when you plug in all those numbers for b, a, and c, when you plug in all those numbers, if that was a negative, we couldn't take the square root in the real number system, so that's why it says that has to be greater than or equal to 0. Realize a is the number before the x squared, b is the number before the x, and c is the constant on the end. That's where you're going to be plugging in numbers here for a, b, and c. All right, let's get into it. Oh, one more to go. I'm sorry. The discriminant, I just talked about this a little bit in the last slide. It says the discriminant b squared minus 4ac has to be greater than or equal to 0. Well, the discriminant is what I have in red here, b squared minus 4ac. That's going to tell us how many solutions there are. We're going to see an example with that so you can better understand it, but the discriminant, b squared minus 4ac, will tell us how many solutions the equation is going to have. This is how we're going to figure out how many solutions there are. If the discriminant is negative, meaning it's less than 0, there are no real solutions. And again, that's because we can't take a square root of a negative in the real number system. If you try to think of like the square root of negative 4, what times itself gives you a negative 4? What times itself gives you any negative number? You're not going to be able to think of anything. You'll learn how to evaluate this in Algebra 2, but to this point, you can't come up with anything. Negative 2 times negative 2 is positive 4. Positive 2 times positive 2 is positive 4. You're not going to get out a negative when you multiply the same thing by itself. If b squared minus 4ac, the discriminant, is equal to 0, you're only going to have one solution. And that's because you are adding and subtracting the square root of 0. This whole thing is going to turn into a big old goose egg, a big old 0 right here. So if you're adding or subtracting a 0, you're not changing the value. So your answer would just be whatever negative b over 2a is. So that's why there's only one solution if the discriminant is 0. And if the discriminant is greater than 0, well, you can take a square root of a positive and get some number out. You're going to add or subtract that number to that negative b value. That's why you're going to get two different answers. So depending on the value of the discriminant, If it's negative, 0, or positive, it will tell you how many solutions your quadratic equation is going to have. Let's get to some examples. Example 1 says, find the discriminant. Remember, the discriminant is b squared minus 4ac. 4ac. And remember, your b, a, and c are just coefficients. So it's y equals ax squared plus bx plus c. So what's before the x squared? That's what a is. So we're comparing this to y equals ax squared plus bx plus c. So what's a? What's right before the x squared? Well, there's an invisible 1. So a is 1. What's before the x? That's where you're going to find b. So I could put plus bx. Well, this is negative x, so there's a negative 1. That's going to be b. And c, well, I'm adding a negative 2 onto the end of this, so c is negative 2. So your a, b, and c are just your coefficients, 1, negative 1, and negative 2. So find the discriminant. Find b squared minus 4ac. So the discriminant b squared minus 4ac is, well, plug in negative 1 for b, and make sure you put it in parentheses because you have to square the entire b value. So you're squaring negative 1. It's not negative 1 squared. It's the quantity negative 1 squared. Minus 4 times a times c. Negative 1 quantity squared is positive 1. We are subtracting a negative. So this is going to become a negative 8, which turns into a positive 8. So if you are subtracting a negative, it turns into a positive. So this is 1 plus 8, or 9. Well, the discriminant is positive. If your discriminant is positive, you have 2 solutions. So I know just by finding that discriminant that I'm going to have 2 solutions. So does this function have 0, 1, or 2 solutions? Well, it has 2 solutions because the discriminant is positive. And again, I know that because I'm going to add or subtract that positive value. If I take a square root of 9, I'll get 3. So I'm going to add 3 for one answer and subtract 3 for the other answer. And that's why there's 2 solutions. All right, example 2, solve using the quadratic formula. All right, so on this one, we have to use the quadratic formula. So let's go ahead and write that down. So again, sing that song to yourself. X equals negative b plus or minus a square root of b squared minus 4ac all over 2a. There's your quadratic formula. All right, so we need to just plug in a, b, and c, and we're going to get our answers. So here we've got a 1 leading coefficient. That's a. B is negative 1. And c is negative 2. So that's the same formula from the last one. All right, so x equals negative b, negative 1, but it's a negative b, negative, negative 1, negative, negative 1. I'm going to just write that. Once you get used to this, you could just put positive 1, but I'm going to write it all out. So negative b is negative 1, negative b, negative, negative 1, plus or minus the square root of b squared minus 4ac. Well, I already calculated the discriminant b squared minus 4ac. I'm going to plug these in on this slide as well, just so you can see where everything is coming from in case you just skipped over the last slide. But I already know that this should equal, I think it was 9. Yeah, that should equal 9. I already know that, but I'll show it on this slide as well. So plug in negative 1 for b, plug in positive 1 for a, plug in negative 2 for c. All over 2a, 2 times 1. So all we have to do is simplify this. We don't have to complete the square where we add the 2 over and then add half of the middle coefficient squared and then solve by factoring. We don't have to do all that. The work's been done to derive the quadratic formula. We just need to simplify. So this is x equals negative negative 1 is 1, plus or minus the square root of 1 plus 8. 4 times 2 is 8. Double negative makes a positive. All over 2 times 1 is 2. So we get 1 plus or minus the square root of 9 over 2. So x equals 1 plus or minus square root of 9 is 3 all over 2. And again, this is a plus or minus symbol. So we have 2 solutions. We have x equals 1 plus 3 over 2, or x equals 1 minus 3 over 2. So plus or minus, that's two different possibilities. One's plus, one's minus. So 1 plus 3 is 4 divided by 2, which gives me a 2. Or 1 minus 3 is negative 2 divided by 2, which gives me a negative 1. So my two solutions, negative 1 or 2. Now I said I didn't know if we'd have enough time to solve by graphing, so I just want to show you so you can at least get exposed to this a little bit. If I were to plug this into some graphing software, I mean, we could graph this one by hand, no problem, but let me just show you to speed this up. I'll plug it into some graphing software. So I'll plug in y equals x squared minus x minus 2. If we were to graph this and find the x-intercepts, because I used a y here, and here y is 0. If y is 0 when you're looking at x-intercepts. See, y is 0, y is 0. We get negative 1 or 2 for the x-coordinates of the x-intercepts. Remember, we called those the zeros. So negative 1 and 2 are the zeros of this function. Well, negative 1 and 2 is what we got by using the quadratic formula. So you can solve by graphing, factoring, completing the square, quadratic formula. You should get the same answers no matter what method you use. It's just some methods are more appropriate in some cases than others. And that's what I started this lesson with. All right, so let's go on to example number 3. Determine how many solutions the function will have by first finding and interpreting the discriminant. Again, discriminant is b squared minus 4ac. So let's find the discriminant. Discriminant b squared minus 4ac. So that's the radicand of the quadratic formula, the piece underneath the radical, underneath the square root symbol. All right, so in this one, notice it's not set equal to 0, so I can't see my a, b, and c just yet. So I'm going to add 18 to both sides. So add 18 to both sides, I get 2m squared plus 12m plus 18. Now I can see that a is 2, b is 12, and c is actually positive 18. So b squared, 12 squared, minus 4 times a times c. If I evaluate this, 12 squared is 144, minus, these are all positive, so it will be a subtraction. 4 times 2 is 8, 8 times 18, 8 times 18 is 144. What we get with that is 0. If our discriminant is 0, we're adding or subtracting 0 in the quadratic formula. So if we add or subtract, I'm just trying to find that slide, this is what I'm looking for. If we're adding or subtracting a 0, again, you're going to get the same value. So really, it's just negative b over 2a, that's my one solution. There's only one solution when your discriminant is 0. So the discriminant here is 0, so I have one solution. I'm going to write down there is only one solution. So that's me interpreting the discriminant being a 0. There's only one solution. And then it says find the solution or solutions if any real solutions exist. And yes, we should have one solution. So let's find it. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I highly recommend you write out the entire quadratic formula. Don't just start plugging in numbers right away. It'll help you memorize the formula the more you write it. So x equals negative b, negative 12, plus or minus the square root of b squared, 12 squared, minus 4 times a is 2, times c is 18, all over 2 times a is 2, all over 2a. All right, so what we end up with, if we simplify this, follow the order of operations, we get negative 12 plus or minus the square root of, we already know the discriminant is 0, so I don't need to redo all this work. I did it on the last one. I'm not going to do that anymore. The square root of 0, I know this will equal 0 because my work's over here. A little squiggle to break it up. All over 2a, 2 times 2 is 4. X equals negative 12. If I add or subtract 0, it does not change the value, so it's negative 12 divided by 4. Which is negative 3. So there's only one solution on this one, negative 3. And again, let me show you how this looks graphically. So if I were to graph the function y equals, we go 2 they're using m. I'm just going to use an x since it's graphing the xy coordinate plane. So 2m squared, 2x squared plus 12m, 12x plus 18. So if you notice this one, there's only one solution. That means there's only one zero. Only one x-intercept exists on this graph, and that's because that's where the vertex is. The vertex hits the x-axis, and then the parabola exists otherwise above the x-axis. It doesn't go through it like that last equation where there was two x-intercepts. It just hits it and bounces right back up. So that's how you get one solution, and that's what it looks like graphically. All right, so your assignment for this section is using the quadratic formula. That is a worksheet, and as promised, I'll go through half of that with you. So this worksheet has 18 total problems, and we are going to go through the even problems right now. You will be responsible for the entire worksheet, but of course you could just copy down my work for the even problems. So all of these require you to use the quadratic formula. So I'm going to write down the quadratic formula up here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. There's my quadratic formula. All right. So what you have to do on this worksheet is simply pick out the coefficients for your a, b, and c, plug them in, and then simplify. I'm sorry, the first thing you actually need to do is find the discriminant to determine how many solutions there are, and then use the quadratic formula to find those solutions if they exist. So on all of these, we do need to find that discriminant first. I'm not going to write this on all of them. I'm just going to write discriminant on the first one. I'm going to do discriminant, which is b squared minus 4ac. All right, so my discriminant on this one, b squared minus 4ac, well, a in this one is a 1. B, and it's kind of tricky because they're using B as a variable. Just pretend those are x's for a second here. So B would be the middle coefficient, negative 4. So this is kind of incorrect by saying B equals negative 4 because you're not actually having B equal negative 4. We're solving for B later on. But I want to be consistent with my examples, so I'm going to still use A, B, and C. All right, and C equals positive 4. So we just need to plug those into my discriminant expression. B squared, negative 4, quantity squared, minus 4 times A is 1, times C is 4. Simplify that, we get 16 minus 4 times 4 is 16, which is 0, so there is one solution. One solution. And then it says, use the quadratic formula to find the solution. So we know how many real solutions there are. There's one solution. So we're going to use the quadratic formula, which is, as I just had up here, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now on this one, it's x equals, but this is in terms of b. So we really should say b equals. And then we're going to plug in our coefficients. So negative 4 plus or minus the square root of b squared minus 4ac, which we already figured out for this with these coefficients, is 0, all over 2a, 2 times 1. Well, adding and subtracting 0 does nothing, so we end up with b equals negative 4 is positive 4, divided by 2 times 1 is 2, so b equals 2 is my only solution, and just to show that that's my solution, I'll put it in set notation. And that's it. You could always double check this if you want. You could plug in 2, and we get 4 minus 4 times 2 is 8, so we're at negative 4 plus 4 is 0. You should get out a true statement. All right, moving on to the next one. So I said I'm not going to write the word discriminant anymore, so I'm just going to say the discriminant b squared minus 4ac. I'll figure that out right here. B squared negative 3 squared minus 4ac. That's going to be 9 plus, because I've got the double negative, makes a positive. 4 times 2 is 8. 8 times 5 is 40. So I end up with 49. So I'm going to have two solutions. Two real solutions. All right, so on this one, if I use the quadratic formula, I get x equals negative b, negative 3, plus or minus the square root of b squared minus 4ac, which is 49, square root of 49, all over 2a, 2 times 2. That turns into a 3, plus or minus the square root of 49 is 7, divided by 2 times 2 is 4. So I get x equals 3 plus 7 over 4, or x equals 3 minus 7 over 4. On this first one, 3 plus 7 is 10 divided by 4, which is 2.5. On the second one, I get 3 minus 7, which is negative 4 divided by 4 is negative 1. Writing those in set notation, negative 1, 2.5. Remember to go in numerical order. I'm leaning towards doing this. I might as well. I'm going to include the answer key with this, but I'm only going to give you credit if you show me all of the work. So you need to have all this work that I'm showing, you should also have for your problem. So negative 1, 2.5, you can double check it on the answer key here. Now notice the authors of this answer key did not put these in numerical order, and also they left 5 halves as 5 halves as an improper fraction instead of writing it as a mixed number, 2.5 or 2.5. So keep that in mind when you're checking your answers. It looks a little bit different, but we got negative 1 and 2.5. Those are our answers, and that matches up. Okay, so again, this one's not numerical order. A bunch of these are not numerical order, but it is what it is. All right, so going back up to here, number 6, we're going to use that discriminant b squared minus 4ac to find out how many real solutions this equation has. B squared is going to be 3 squared minus 4 times 2 times negative 20, which turns into 9 plus, because of the double negative. 4 times 2 is 8, times 2 is 16, with another 0, 160. So 169 gives me 2 solutions, 2 real solutions. Using the quadratic formula, I can find those solutions. Negative x equals negative b plus or minus the square root of b squared minus 4ac is 169, all over 2 times a, 2 times 2. So that's x equals negative 3 plus or minus the square root of 169 is 13 over 4. So x equals negative 3 plus 13 over 4, or x equals negative 3 minus 13 over 4. So we get 10 over 4, or negative 3 minus 13 is negative 16 divided by 4. So x equals 2.5, or negative 4. And again, put those in numerical order, negative 4, 2.5. Those are my 2 solutions. All right, moving on, number 8, discriminant b squared minus 4ac. B squared, the quantity negative 7 squared, minus 4 times a times c. Oh, what do you notice about this one? It's a little bit different than the other ones. It's not set equal to 0. So on this one, I need to add 10 to both sides first to get it set equal to 0, so I know what my a, b, and c are. So this is 2m squared minus 7m. If I add 10 to both sides, this is just a minus 3, and then it equals 0. Now I can see what a, b, and c are. So the c is actually negative 3. Negative 7 quantity squared is 49, minus a negative is a positive. 4 times 2 is 6. 6 times 3 is 18. So we get 5967. So this one is not a perfect square, so this is going to be kind of a nasty looking answer with some square roots in it, but that's okay. We can still use quadratic formula. We still know that there are going to be 2 solutions because we got a positive number for our discriminant. Use the quadratic formula, x equals, but now we're not solving for x. Just want to double check on these. Yep, solve for b here, x there, and now we're not solving for x, we're actually solving for m, because my equation here has an m in it, so m equals negative b, negative 7, plus or minus the square root of b squared minus 4ac, we get a 67, all over 2 times a, 2 times 2. That turns into 7, double negative makes a positive, plus or minus the square root of 67 over 4. And as I'm doing this, I just realized I made a mistake over here. I apologize. This is a negative makes a positive, but 4 times 2 is 8 times 3 is 24. I don't know what I was doing here. I don't know if I said the right thing and wrote the wrong thing or just did the wrong thing. I don't know. Anyway, so that should not be a 67. My apologies. Let me just erase this here. So that's going to change this 67. That's all right. All right, so this should be 4 times 2 is 8 times 3 is 24. And that, if you add these together, you're going to get a 73. So that's what my discriminant should have been. All right, but the same issue still stands. 73 is still not a perfect square, so my answer will still have some square roots of 73 in there. If you try to break down 73, it's not going to happen, and that's because, again, you can just do this to speed it up a little bit. Is 73 prime? And it's going to say, yep. So 73 is not going to break down into anything else. You're not going to have any perfect squares hiding in there. So I can still write this in set notation. I can say 7 minus square root 73 divided by 4. That's one answer. And the other one is 7 plus square root 73 divided by 4. You don't want to plug that into your calculator because if you do, you're going to get some nasty decimal because 73 is not a perfect square. If you take the square root, you get an irrational number. So it's a decimal, non-repeating decimal that goes on forever. You'd be rounding your answers if you did that with your calculator. So just leave it like this. That's a perfect answer. That's an exact answer. So that's a good answer. All right, on the next side here, number 10. Keep on going with the same thing. We need to subtract 2 from both sides. Plus 2x minus 3 equals 0. The reason that I need to make this equal to 0, I don't think I said this yet. The reason it has to be equal to 0 is because that's where the quadratic formula comes from. So if I go back to my proof, if I can find where I left it here, the proof of the quadratic formula, it comes from having ax squared plus bx plus c equal to 0. So you have to get it into this form in order to use it because that's where it was derived from. So here, if it's not equal to 0 to start, we've got to get it equal to 0 to start so that we can see our a, b, and c coefficients. So again, find the discriminant b squared minus 4ac, which is going to be 2 squared minus 4 times 1. There's an invisible 1 out here. Times c is negative 3. And that's going to be 4 plus, because of the double negative, 4 times 1 times 3 is 12, which is 16. So we're going to have 2 solutions on this one, 2 real solutions. 2 solutions in the real number system, that is. All right, so what we end up with here with the quadratic formula is x equals negative 2 plus or minus the square root of b squared minus 4ac is 16, all over 2a, 2 times 1. So x equals negative 2 plus or minus the square root of 16 is 4 divided by 2. That's a bad looking 2. There we go. All right, so we get negative 2 plus 4 divided by 2, or negative 2 minus 4. Make that a little bit better over here. X equals negative 2 minus 4 divided by 2. So one solution, negative 2 plus 4 is 2. 2 divided by 2 is 1. On the other one here, we get x equals negative 2 minus 4 is negative 6 divided by 2 is negative 3. So my 2 solutions, negative 3 or 1. Going on to number 12. This one, it does say in the directions, find the discriminant and then use the quadratic formula. So although this one would be easier to solve using square roots, we're going to follow the directions on here and we're still going to use the quadratic formula. So how do I make this look like this? Ax squared plus bx plus c equals 0? Well, subtract 80 from both sides. So I have 5r squared minus 80 equals 0. That still doesn't look like an ax squared plus bx plus c, or ar squared plus br plus c equals 0. So what is that middle coefficient if it's not there? Well, the middle coefficient if it's not even there is a 0. So I have 0r minus 80 equals 0. This is the excuse me, this is the exact same thing as the previous line. Because there is no r term, no linear term, so there's a 0r. All right, moving on. My throat is starting to hurt. I've been talking too much. What we have now for the discriminant b squared minus 4ac, we have 0 squared minus 4 times 5 times negative 80. So finding the discriminant here. All right, so 0 squared is 0. Double negative makes a positive. So we have 0 plus 4 times 5 is 20. 20 times 80 is 16 with 2 zeros. So we end up with a 1600. So we're going to have two solutions, two real solutions on this one. Two solutions. Using the quadratic formula to find those two solutions, we have x equals, or r equals in this one, because it's an r equals negative b, negative 0, plus or minus the square root of b squared minus 4ac, the square root of 1600, all over 2 times a. 2 times a is 5. Well, negative 0 is equivalent to 0, so 0 plus the square root of 1600 is 40, or 0 minus the square root of 1600. So we end up with positive 40 divided by 10, or negative 40 divided by 10. 40 divided by 10 is 4, or negative 40 divided by 10 is negative 4. So those are the two solutions for this one. All right, 3 more to go here. So number 14, add the 4 to the other side. We get 5x squared plus 9x plus 4 equals 0. Use the discriminant to find how many solutions you have. B squared is 9 squared minus 4 times a times c, 4 times 5 times 4. So I've got 9 squared is 81. There's no negative over here, so it's minus. 4 times 5 is 20. 20 times 4 is 80. And 81 minus 80 is 1. So since that's positive, I will have two solutions. And let's find those solutions using the quadratic formula. So x equals negative b, x equals negative 9, plus or minus the square root of b squared minus 4ac, which is a 1, all over 2a, 2 times 5. So we end up with x equals negative 9 plus the square root of 1, which is 1, divided by 10. Or x equals negative 9 minus 1 over 10. Negative 9 plus 1 is negative 8 divided by 10. So negative 8 tenths is negative 4 fifths. On the other one, we get negative 9 minus 1 is negative 10 divided by 10 is negative 1. So on this one, my two solutions, negative 1 or negative 4 fifths. Going down to number 16, just two more to go. On this one, we need to get everything to one side, so we have 9n squared minus 7n if I subtract 7n from both sides, minus 4 if I subtract 4 from both sides, equals 0. So my discriminant, b squared minus 4ac, right, the discriminant is going to turn into negative 7 squared minus 4 times 9 times negative 4, which is 49 plus, because I have the double negative, 4 times 9 is 36. 36 times 4, 144. Adding those together, we get 193. Again, not a nice number. This is not a perfect square, so I believe that one is also going to be a prime. Is 193 prime? Yes, it is. So on this one, we are not going to be able to break down the square root of 193 any farther. All right, so there's my discriminant. I know that because it's positive, I'll have two solutions. Two real solutions. All right, so now I've got n equals negative b, negative negative 7, plus or minus the square root of b squared minus 4ac, which is 193, all over 2a, 2 times 9. So this one becomes negative negative 7 is 7, plus or minus the square root of 193 divided by 18. And write that in set notation, 7 minus the square root of 193 divided by 193 divided by 18, or 7 plus the square root of 193 divided by 18. All right, last one. So on this one, it's already in standard form. We're good to go. It's ax squared plus bx plus c equals 0. We've got the discriminant b squared minus 4ac, which is negative 3 quantity squared minus 4 times 5 times c, which is 1. So we get 9 minus, because there's no negative. 4 times 5 is 20, times 1 is still 20. 9 minus 20 is negative 11. So this is the first time we've run into a negative. We can't take a square root of a negative. So when I go to plug this in, when I go to plug in negative 11 into my square root in the quadratic formula, I can't take a square root of that in the real number system. So there's going to be no real solutions. So you could try to set up the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac is negative 11 all over 2 times a. But when you try to evaluate this right here, you cannot square root a negative number in the real number system. Because again, think of two numbers. When you multiply by themselves, you get a negative number. It's not going to happen. You'll learn about imaginary numbers and complex numbers in Algebra 2, but in this Algebra 1, you just say, no real solutions, therefore we're done. And let me show you this one graphically. This is the last one I'm going to show you for this assignment, but let me show you what this looks like. So if you try to solve this graphically, get that out of there, that's the last one. Plug this in here, I get y equals 5x squared minus 3x plus 1. So if the zeros, the x-coordinates of the x-intercepts, are your answers, well, you don't have any x-intercepts. That's why you don't have any real solutions. There are no values of x that make y equals 0 in this equation because it doesn't hit the x-axis. So that's your lowest point. Obviously, y is not 0. Okay. All right, so again, you need to finish this worksheet, but please also complete the even problems. You can just copy down my work, but use these to help you with the other problems. As I scrolled through this quickly, I think some students are going to look at number 15 and go, what do I do with that? Remember, you're trying to get it equal to 0, so just add all of these to the other side, and then you can go on with the quadratic formula, or finding the discriminant and then using the quadratic formula. So add everything to one side, get it set equal to 0, then use the discriminant, and then the quadratic formula. And again, I'll post this with the answer key, so you're going to be able to see what you should get, but I'm only going to give you credit if you show me the work. All right, thank you.